Solar flares are one of the most fascinating phenomena in our solar system. Imagine the sun, a massive ball of gas, constantly bubbling and churning with energy. Every so often, it releases bursts of radiation and charged particles that can travel millions of miles through space. These bursts are what we call solar flares. A solar flare occurs when magnetic energy that has built up in the solar atmosphere is suddenly released. This release can produce a flash of light that is brighter than the sun itself, emitting energy across the entire electromagnetic spectrum, from radio waves to X-rays and gamma rays. The energy released in a single solar flare can be equivalent to millions of hydrogen bombs exploding at once. That's a staggering amount of power. These flares can last anywhere from a few minutes to several hours, and they can have significant effects on Earth. When they reach our planet, they can disrupt radio communications, navigation systems, and even power grids. In extreme cases, a strong solar flare can induce currents in power lines, leading to widespread blackouts. The 1989 geomagnetic storm caused by a solar flare knocked out power for 6 million people in Quebec, Canada, for 9 hours. But it's not all doom and gloom. Solar flares also create beautiful auroras, those stunning displays of light that dance across the polar skies. When charged particles from a flare interact with Earth's magnetic field, they can produce the mesmerizing colors of the northern and southern lights. It's nature's own light show, a reminder of the sun's power and influence. Scientists are constantly monitoring solar activity to predict when these flares might occur. They use satellites equipped with advanced instruments to observe the sun in real time. One of the key missions is the Solar Dynamics Observatory, which captures high-resolution images of the sun's surface. By studying these images, researchers can identify sunspots and other indicators that might signal an impending flare. Interestingly, solar flares are often associated with sunspots, which are cooler, darker areas on the sun's surface caused by magnetic activity. The more sunspots there are, the more likely a solar flare will occur. This is part of the solar cycle, an approximately 11-year cycle of solar activity that includes periods of high and low sunspot numbers. Solar flares remind us of the sun's dynamic nature and its impact on our planet. They are a testament to the power of the universe and the intricate dance of magnetic forces at play. As we continue to explore and understand these phenomena, we gain insights not only into our sun, but also into the fundamental processes that govern our solar system. So, the next time you look up at the sun, remember that it's not just a source of light and warmth. It's a powerful force that can unleash energy beyond our imagination.